In this video, we're going to solve an integral backslash int do. We'll specifically be handling the integral of 1 over 1 plus tangent of x with respect to x. When solving integrals like this, a common technique is to use a substitution to simplify the integrand. In this case, let's consider the trigonometric identity for tangent. Tangent of x is sine of x divided by cosine of x. With that in mind, the denominator in our integral, 1 plus tangent of x, can be rewritten using this identity. Doing so, we see that 1 plus sine of x over cosine of x is the same as cosine of x plus sine of x all divided by cosine of x. Now, the integral becomes 1 over cosine of x plus sine of x all divided by cosine of x, which simplifies to cosine of x divided by cosine of x plus sine of x. This makes it more apparent how we can substitute. By setting u equals cosine of x plus sine of x, the numerator becomes the derivative. Cosine of x minus sine of x times dx becomes do. Let's set u equal to cosine of x plus sine of x. This substitution simplifies our integral. Do is minus sine of x plus cosine of x times dx, or equivalently, cosine of x minus sine of x times dx. Thus, the integral becomes the integral of 1 over u times do. Now that the integral is simplified, let's go ahead and evaluate it. The antiderivative of 1 over u is the natural log of the absolute value of u plus our constant of integration c. Now, we'll revert our solution back in terms of x by substituting back our expression for u. Cosine of x plus sine of x. Our final solution becomes the natural log of the absolute value of cosine of x plus sine of x plus the constant of integration. And there we have it, a complete solution to our integral problem using substitution and trigonometric identities. Substitution can often provide deep insights into integral problems.